Okay, today we're going to talk about oxidation numbers, and assigning oxidation numbers is important for understanding oxidation reduction reactions and what happens in these redox reactions. So there's a number of rules for determining your oxidation numbers. First rule is if you have an uncombined atom or diatomic elements or a polyatomic molecule, it's going to be assigned an oxidation number of 0. Oxidation numbers are going to be written above the atom element, not to the side. The one to the side is going to be the charge. So uncombined atom, if you have zinc, it's going to get an oxidation number of 0. Diatomic element, remember they're atoms that have to be combined with something else or themselves. So for example, hydrogen is going to get an oxidation number of 0. A polyatomic molecule, so something like sulfur 8, is going to get an oxidation number of 0. They're all by themselves, therefore their oxidation number is going to be 0. If you have a monatomic ion, you're going to give it the charge that is on the ion. So for example, calcium has a 2+ charge, therefore it's going to have an oxidation number of +2. Bromine has an oxidation number of -1, 1 negative, so, its charge is -1, so therefore its oxidation number will also be -1. So for a monatomic ion, the oxidation number is going to be the charge. So remember, this up here is the oxidation number. And this is the charge. Sorry, I can't spell. If you have a molecule or a complex ion, you're going to start with the most electronegative atom that is there and assign it its charge as if it were an ion. So if you have ammonia, which is NH3, your most electronegative element here is nitrogen. Nitrogen typically forms a 3 negative charge, so you would assign it a -3 oxidation number. If you have SiCl4, your most electronegative atom is chlorine. Chlorine typically forms a -1 charge, so you're going to assign it a -1 oxidation number. Fluorine is going to be easy. Always gets a -1 if it's bonded to another atom. So if you have HF, hydrofluoric acid, you're going to assign fluorine a -1 oxidation number. Now, oxygen has a few different rules. Typically, it's going to be a -2. So if you have water, the oxidation number for oxygen is going to be its -2. If it's in a peroxide, though, and the only peroxide I would give you in this class is hydrogen peroxide. If it's in a peroxide, you're going to assign it an oxidation number of -1. And if it's bonded to fluorine, then it's going to have a +2. So OF2. Remember, we said fluorine always gets a -1, so therefore the oxygen is going to have to get an oxidation number of +2. With hydrogen is typically going to be a +1. So if we look back at our water, we said oxygen was going to get an oxidation number of -2. The hydrogen would get a +1. When we looked at ammonia, we said that nitrogen got a -3. Hydrogen is going to get a +1. So typically the hydrogen will get a +1. For your groups 1A, 2A and just aluminum, not the group, just aluminum, the oxidation number is going to equal the number of valence electrons. So you have NaCl, sodium is in group 1A, you're going to give it a +1 oxidation number. If you have aluminum chloride, aluminum has 3 valence electrons, therefore it's going to be a +3 oxidation number. When you have a neutral compound, your oxidation numbers need to add up to 0. So you're going to multiply just like when you're trying to do your charges. So if we look at our ammonia again, start with our most electronegative atom, that's nitrogen. Nitrogen is going to get a -3 oxidation number. Hydrogen, we say, gets a +1. So now mathematically, does this work out? Well, we have 1 nitrogen, so 3 times 1, or -3 times 1 is -3, plus 1 times 3 is 3. So -3 plus 3 does in fact equal 0. So that works out mathematically. For an ion, polyatomic ion, the oxidation numbers need to equal the charge on that polyatomic ion. So let's say you have NH4 plus, you're going to start with your most electronegative atom, which is nitrogen. Nitrogen, we said, gets a -3. So to get to a +1, you're going to give hydrogen a +1. So if we check our math, 3 times the 1 nitrogen is a -3. 1 times 4 is 4. So -3 plus 4 equals 1. And in fact, our charge is a +1. So that works out as well. So some examples to try. You have KClO3. So go ahead and pause the video. Try this one. You're going to start with the most electronegative atom, which is chlorine. Chlorine is going to be assigned a -1. That's its charge. Oxygen, we said, typically always gets a -2. So since this is a neutral compound, we're trying to add up to 0. So -2 times 3 is -6. -1 times 1 is -1. So you're trying to figure out what to give the potassium so that we get to 0. So what are we going to give potassium to get 0? Well, -6 minus 1 is a -7. So you're going to give the chlorine, going to give the chlorine a +7. And so then that adds up, 7 minus 1 is 6, minus 6 more is 0. Let's see if I can erase this. No, I can't. So we'll write it over to the side. So your next example is SO3 2 negative. So you're going to assign your most electronegative element what its charge is. In this case, that would be oxygen. So it will receive an oxidation number of -2. In this case, we are trying to get to negative for our answer. So negative 2 times 3 is negative 6. We're trying to get to negative 2 for our answer. So we are going to assign sulfur a plus 4. So that 4 minus 6 is negative 2. Your next example there is SB205. This is a neutral compound, so you're going to want them to get to 0. So oxygen is always going to get its negative 2. Negative 2 times 5 is negative 10. We want to get to 0, so that means we need to get 10 here. So plus 5 times 2 gives you 10. And our next example is MnO4, 2 negative. So we're trying to get to a negative 2. Oxygen, going to get a negative 2. Negative 2 times 4 is negative 8. We're trying to get to a negative 2 answer. That means that what we have to put here is a 6. 6 minus 8 is negative 2. So you're going to assign manganese a plus 6 oxidation number. So not all of the elements are going to follow what their charge normally is. So start with the ones that have a specific rule and then go from there. Always start with your oxygen or your fluorine. They're typically always going to be the same. Fluorine is always the same. So start with your oxygen or your fluorine. Then, if you don't have either one of those present, go to your most electronegative. Assign that one its oxidation number. And once you've exhausted those options, then go ahead and work through to the ends, saving whatever's weird for last.